Hey there viewers, and welcome back to the South Main Auto channel. Got this 2002 Honda Civic Coupe with the 1.7 liter here and the money lights on, and we're going to plug in our Autel here. As a matter of fact, it's just about done scanning. I got it on an auto scan feature and it's going through to check all the different modules and see why the light's on, and I'll bring you guys along and we'll see if we can do some testing and kind of check out the new Autel a little bit. We've been using it in some of the other videos and been using it quite a bit. Been kind of taking a pretty good liking to it. So let's see what we got. So it's all done scanning. You can see we got one code in the airbag. Imagine that. These things have a heck of a time with the driver's side seatbelt switches. They actually got a lifetime warranty on them. And it's not be running. Let's just see what the airbag light is. It's probably that. Let me go switch it off. Send a lot of these back to the dealer to get the airbag lights, or the I don't say the airbag light, the actual driver's side seatbelt switch in these. Yeah, faulty driver seatbelt switch. Good guess. Alright, let's go back to where we were. I bought a stylus. It doesn't work that good with the screen protector, but sometimes if your mitts are all grubby, sometimes it's easy to grab this, but there are some features where you have to drag some things and expand and contract different items. So the stylus is kind of handy, kind of not handy, but it's kind of a 50-50. So we'll go in here, we'll see what codes it has stored in it. So it has a code sensor 1 voltage low. I don't know what the little question mark does. I'm still getting used to the tool. Let's see, sensor failure. Oh, okay, so it gives you a couple kind of possibilities, a little different code definition, nothing really too significant. Let's see, we'll go into some data. Let's see if the freeze frame data has anything stored. I don't know, they usually don't store O2. Well, it does. Okay, so there's a clue. We can see our O2 sensor is at 0 volts. I would say that is low voltage, and our fuel trim is pegged out at 47%. So your Honda fuel trims, they use that 1.00. So the 1.00 it would be 0%. So these, we look at these a little different. The 1.47 is trying to make up for a excessively lean condition, which this O2 sensor is indicating. So if we have our downstream O2 sensor right here, and that's at 1.02 volts, so we can see that this is clearly a lie in the sense that our downstream voltage is pegged out high, our upstream voltage is 0, fuel trim's pegged out, so we can tell the fuel trim is buried and the computer's responding because the downstream O2 sensor is, that's at its max adaptive, or its max limit, 1 volt. That thing is running super rich because that's what the computer's commanding it to do. So we can get all this information just from looking at the freeze frame. And let's see when this happened. I like to look at temperature. So the engine's fully warmed up, going down the road 55 miles an hour at 3,700 RPMs. So just kind of cruising down the road, and it must be kind of an intermittent condition because you can see our long term is only at 1%. So must be at spiked out temporarily and then just threw the money light on. So I say we try to duplicate this. We'll go in and look at some live data. Where's that? Right here, live data, and we'll sort out we'll just look at our O2 sensors. So we'll get this, and we'll get coolant temp. Oops. Yeah, see, the stylus isn't that great. Works great on my phone though. We'll get our oxygen sensors, short term, long term. Yeah, that should be Let's see, do we got a loop status? Here comes the choo-choo. I don't know. I don't know. I might have just skipped past it. You guys are screaming. There we go. Is this... I don't know. No, it's speed control switch or something. I don't know. Oh, open loop. There we go. Fuel system. Probably FSS. That fuel system status. What is that? Fuel system status. Look at me. Okay. So then we're going to go to show. We're going to go ahead and fire this up, and we're going to watch. Primarily, we're going to be watching our oxygen sensor, which is, so this is sensor 2. It's our downstream. So our upstream, you can see our downstream has a bias voltage on it, and it appears that our upstream, so that could be a clue also. So our downstream is at 4.1. I assume it has a bias voltage, and our upstream is at 0.92. I would think that would be at or near 5 volts like our downstream, but that could indicate a problem also. Let's fire it up and see what we got. Well, we got no comm right now. We got no RPMs. What the heck? Let's see if I bump the connector. Hang on. That was my fault. Must have hit it with my foot. I gotta go back in here and select this again. I tell you what. Let me shut it off. I don't want to miss something critical here. So what do we have? And that. I would say that is the one drawdown between the Autel and the Snap-on Verus is when you select a custom data list, it doesn't save it, which is kind of a stinker. Okay, I think that's all we had. Let's go to show. Okay, let's start this up again. All right, there we go. Now we're in business. So we're going to graph our O2 sensor here. Slow it down. Let's see, our rear O2 sensor, we'll just watch down here. I don't think we really need to graph that. We'll kind of pay attention here to what's going on. So right now our fuel trim is short term, about 8%, thereabouts. It's already in closed loop. Goes into closed loop pretty quickly. Give her the old rev up here, see what happens, see how it responds. Try not to knock the connector out. Put it in. Well, there it goes right there. So it just stuck at, you see that? We're just stuck briefly at 0. It's pretty interesting. That thing seems super lazy. That and just the fact that, when it's kind of oscillating there, boy, it's really hanging around that lean condition mark quite a bit. We can see looking at our downstream O2 sensor, it's definitely not the case. We're only up 150 degrees. Maybe the warmer it gets, the worse it gets. It's kind of what it's looking like as the car's warming up. We're getting some really big really big flat spots in that. It's really taking a long time to respond to the fuel trim change. Fuel trim kind of climbs up, 1% or so there. Let me see if I can warm this up a little bit more. It's even sticking quite rich there for a while, enough to where it knocked the fuel trim back a few points. So it appears, just looking at this, the rate at which it transfers data from the computer to our Autel here seems a little bit slow. I don't know if we should be seeing, what the rate of transfer is. It's obvious that this O2 sensor is sticking down real low for a long time, waiting for the PCM to kind of bring it back up. We can just grab the scope for this and we can plug right into the O2 sensor. I think the connector is easy to get to. We'll kind of back probe that and see what it looks like on a scope, real-time data versus this here, being that we know it doesn't look like the car's, indeed running lean for real, and appears to have the ability to control fuel trim and stuff. So I say we do that, and then we'll determine if we got a bad O2 sensor here, but that's what it's looking like. So here's our O2 sensor. We'll just kind of get, or our O2 sensor connectors right there. And just kind of a visual inspection, you can see most of the harness. I don't see where it's, chafed through or anything, looks damaged or anything. What I'd say we do is just do some quick checks. We'll see if I can't get this unplugged. And that could be a challenge in and of itself. Well, anyhow, I'll get some pliers here. We'll get that unplugged. Just real quick, we'll check to, because it is kind of a slow response, low voltage, let's just make sure real quick the heater works. I would assume if it didn't, we'd have a code, but that's one quick and easy check we can do on an O2 sensor. I've seen some slow response and low voltage codes come as a result of a non-functioning heater that didn't throw a code, so let's have a look. Okay, so I got it off its connector. So the first thing we'll do is we're just going to check the heater circuit for resistance in the O2 sensor. So we don't even have to look at a wire diagram. We know it's the two wires that are the same color. That's the way I don't want to say always because I could be wrong, but that's the way it usually is, we'll say. We're not even really concerned with the actual, hopefully set this up where you guys can see it, the actual measurement is. We're just going to check for continuity. Usually it's about, 6 to 15 ohms, somewhere in there. So I'm just going to use our meter here. Make sure our leads here are good. Yeah, that's good enough for what we're doing. And we'll come across the two white wires in this case. Let's see what we got. That's 7.8 ohms. Of course, we've been running it, so that seems good to me. We know our heater circuit is good inside the O2. And then we can just check real quick on a voltage scale and make sure that the car is putting out the 12 volts required for the O2. Alright, I changed my mind. We're not going to use the voltmeter because that usually won't give us enough good info. We're going to take and just hook our test light across the terminals real quick. Find out which two they are. So it is the two towards my thumb, so just to be able to get in there easier, I'm just going to use some jumper wires. Some cars, I don't know because I didn't look, need to be running to turn the heaters on. And some cars will have the heater work key on, engine off, so we're going to find out which way this is. So we'll just go like this. So when our heater turns on, our test light should light up. So we're going to turn the key on. We're going to take and turn the key on and see what we've got. Is the key on?
Yeah.
Hannah? Okay, just start it. So there we go. Okay, shut it off. Okay, that's good. All right, so that proves that our heater circuit is good, so we don't have to worry about that or think of that as a variable. So now we can just kind of focus on the actual O2 sensor, kind of get a look at that. It appears that it has a good connection to the scan tool. It's reporting back anyways, but we'll do some quick tests there. Move on. So another thing we can do is we can pull up, we'll pull up some data, and everything's plugged back in now. So we'll get our O2 sensor data. See, now we've got a bias voltage on there. That's what I was just going to check. So something has changed since we've unplugged it and plugged it in. I'll get the camera moved here. So I moved the camera. I've got the connector unplugged. Let me just re-identify who's who here. It's going to be these top ones. So what we're going to do is we're going to use the test light. We're just going to kind of verify circuit integrity here. We're going to take our test light. We're going to hook it to, actually we can start out hooking it to positive. Make sure we got that. And essentially, what we should have is we should have a signal return wire and we should have a ground. So that's our ground. So we know we have a good ground on our connector here. We know our two bottom wires here, which was our heater, we know they work. We know we have a good ground. And then using the test light to check this is perfectly safe. And then what we want to do is we're going to switch our test light over to a ground. Make sure that works. And then we're going to go on our signal return wire and make sure up here on our scan tool that it pulls our voltage down from the bias voltage that it has of 4.08, pulls it down to 0. Okay, so we have the data stream pulled up here, and you can see that our O2 sensor is at 4.08. We know the heater's good, we know the ground is good. I got my test light hooked to ground, and as I touch the signal return wire, it simply goes to 0. So that proves that our wiring to the PCM is good. When I remove it, it goes up. So that is definitive that our O2 sensor is circuit-wise is perfect. It's all there, everything we need. I think just for the fun of it, we can take and hook it to our scope and have a look at the waveform it puts out in comparison to the new one. I'll get the new O2 sensor ordered up, get it here, and we'll compare new to old. And we'll also look at, I think it's good to kind of understand the rate of transfer from the ECM to our scan data by the time it gets processed, how much slower this is than actual real life testing. So that's kind of a good thing to look at. So I've got our positive and negative lead hooked to the red lead's going to be hooked to the signal wire on the O2 sensor, which is the black wire, and I got the ground hooked to the ground wire on the O2 sensor, which is the gray wire. And we're going to have to hook this to the Varus. Now, unfortunately, the Autel, it does have a scope, and the scope works okay, but the scope has some very limited features, and one of the features it does not have a built-in filter. So when you hook to a signal like an O2 sensor, it's so hatchy that you can't even begin to make sense of it. If the Varus fires up, hopefully, cross your fingers, if that works, then we're going to use the scope on that to look at the O2 signal, where we can actually filter out all the hatch marks on it. All right. Well, I thought we could set up the Ferris, but we got our typical Ferris problems. It's going to take us 45 minutes to get it up and running to do a simple test, because this is where we're at. This is where we're at every time we use it. And you send it in and they charge you $1,300, and then you get it back and you get, I don't know, a good solid 5 minutes of using it. This thing is the most frustrating tool I've ever owned in my life. It's constant. You're a solid half an hour each time you want to use it just to get it turned on and running and prevent it from locking up. So, but hey, you know, they're like 10 grand. What do you expect? Okay, third time's a charm. Now that I've pissed and moaned enough about this tool again. So what we have here is we actually have the lab scope. It's our live data. This is the data we see on the car. We can see our O2 sensor essentially is just flatline. So this is kind of interesting. You know, we're getting these glitches in the PCM. So that's kind of interesting. Saying right now is, oh, never mind. I wasn't looking at my min-max scales. So we've got our live data over here, 0.400, probably hard to see, but basically we're going to look at our oscillations, our trace, which we have no oscillations currently, but we'll see if we can establish some min-max here. We can see it went lean. See it dip down. Let's see if we can change our scale here. Change that to 1 volt. Let's see. I don't remember how to get that back down. We want that displayed. Oops. Let's see here. Okay, there we go. Yeah, I mean, we have no oscillation. So I tell you what, you know, we know our O2 sensor is nuked. Let's replace it and then redo this test to kind of look at it to see what we have, so we can actually see a working oscillating O2. All right, we've got the new one installed. We're probably going to get a no-com issue again. Let me go ahead and fire it up here. Oh no, we didn't. I was gonna say, a lot of times when you crank them, let's get some fuel trim up here if we can too. We'll graph that again. Open up our scope. We'll move that down a little bit. Okay, so this is just starting, and we can already see. We can see a difference here. But I think the main thing we wanted to look at was, let's see, can we zoom in? Okay, I just wanted to get these kind of on the same time basis, but to see the difference of what the scope's showing versus what's actually going on at the O2 sensor, just kind of give you an idea. Let me give her some gas here. So I think this is a good example of live data versus process data, because as you might, so we got a good oscillation here from like what, 0.2 volts to 0.9 roughly. But when you look over here on the live, or on the data that you were seeing on your scan tool, you can see how this might trick you. If you weren't really aware of this, that the PCM is processing this data before it sends it to your scan tool, versus actually, this is real time what's going on at the O2 sensor, currently. Oops. Oh, somehow we changed our time scale here. Oops, sorry. There we go. You're back in recording. There we go. So there's live data. There's process data, and you can see the difference. Not so much when we're sitting here at a, at an idle. Let's get this back up. Pretty similar. Not bad. But when we get the data at a high speed here, you can see process data versus real data. I think it's a big difference, but just kind of give you an idea. But there's our oxygen sensor. We proved it. That's what was wrong. It works. Well, there you have it, viewers. Got this little tuner ready to go back on the road, back at the drift track, and start doing some VTECing. But you can see that it was pretty quick and easy to diagnose this O2 sensor, and essentially just with scan data and a couple quick tests, we can unplug it. We can test the signal wire going to the PCM just by touching it with a test light and running it to the ground and looking at the bias voltage that it had online when we unplugged it. Kind of confirms that wire's good. Tested the ground, tested the heater circuit, and 1-2 barbecue. She's all done. But it was kind of an extra unnecessary step to throw it on a lab scope to have a look at real-time data versus scan tool data, because you just always got to keep in mind that the stuff you see on your scan tool is processed by the PCM and then shipped out the other end up to your scan tool for us to look at, and you can see the difference there, and a pretty substantial difference, I might add, particularly when the oscillations start to move much faster, and you can see that the PCM processing it and putting it on your scan tool just couldn't keep up. But still, it gives you a pretty good idea as to what's going on, and in different cars that transfer at a different rate. Some of the later model stuff transfers at an extremely high rate, and so just kind of keep that in mind. So hope you guys enjoyed the video. If you did, give us a thumbs up. The jury is still out on the Autel lab scope. Not 100% satisfied with it. But again, we're looking at a $500 scope, which is kind of unheard of for an oscilloscope. But plugged it in. I was going to use it on this O2 sensor, and the signal is so choppy and so full of noise. It was ridiculous. They're supposed to have some software updates. I don't know if that'll repair that problem or what their thoughts are. I guess some more on the Autel. The scanner portion of it is phenomenal, particularly on late model stuff, Fords and Toyotas and Hondas. It's been absolutely wonderful. Lab scope, so-so, not the greatest. Tech support, when you call to ask them about the scope or updates, and it depends on who you get to talk to, when you get to talk to them, what your answer is. And the scope is pretty new. It's brand new to them. They don't know a ton about it. Chinese-owned company. We'll see how that turns out in the end. I won't leave you out in the air on that, because I kind of want to know myself. I got some money tied up in it, and we'll see where it ends up. But yeah, at any rate, thumb up the video if you like it. Just leave some comments in the comment box below if you got any questions or concerns or criticisms, anything like that. Check us out on Facebook if you haven't. Find us on Google Plus too if you want to connect with us socially there. And just remember, viewers, if I can do it, you can do it. Thanks for watching. forget.